Okay guys, this is factoring using the difference of squares. This is the second factoring topic we're talking about. Remember that factoring is to break things down into a product, so it's going to be things that are multiplied. And we're going to talk about what it means to have a difference of squares. Okay, so right now in your graphic organizer at the very top you see 3 problems, and I ask you to fill out those problems. So just take a second now and fill out those 3 problems, and we'll take a break from the video and come back and check your answers. So do that now, please. Okay, now that you've had some time to fill out those 3 problems at the top of the graphic organizer, let's take a look at the answers of what you get. Okay, the first one states x plus 2 times x minus 2. Okay. Hopefully you're going to find a pattern here. Well, filling things out, just a reminder, first, outer, inner, and then the last. In blue I have the first, x times x is x squared. Then I have the outer, x times negative 2 is negative 2x. Then the inner, which is 2 times x is 2x. And then the last, 2 times negative 2 is negative 4. Hopefully you saw that this reduces, and this negative 2x and this positive 2x cancel each other out to leave you with a final answer of x squared minus 4. Okay. Now usually when we multiply 2 binomials we end up with a trinomial. In this case we end up with a binomial. Okay. See if we find a pattern here. Okay, next problem. Same thing, binomial times binomial. X minus 10 times x plus 10. First, x times x is x squared. Outer, x times 10 is 10x. Inner, with the orange arrow here, negative 10 times x is negative 10x. And last, negative 10 times positive 10 is negative 100. But again, these terms that are in the middle, the x terms cancel out. So what you're left over with, after you gather your like terms and simplify, is x squared minus 100. Hopefully you're picking up on a pattern that we have the same binomial here and here. The only difference is the sign in the middle. Okay. All right, one more. 3x plus 5 times 3x minus 5. Same thing here and here, except for the sign is different in the middle. The pattern on the last 2 was that the middle term disappeared or canceled each other out. Let's see if that holds true here. First, 3x times 3x is 9x squared. Outer, 3x times negative 5 is a negative 15x in the green arrow. Inner, 5 times 3x, the orange arrow, which is 15x. And last, 5 times negative 5, which is negative 25. Get your like terms together. Remember, like terms have to have the same variable raised to the same power. Negative 15x plus 15x, they go away. What are you left over with? 9x squared minus 25. Okay, so what are these things? What do you notice about the product of these binomials? Well, the binomials look exactly the same except for the sign that's different in the middle. And instead of getting a trinomial, we end up getting a binomial. This is a special binomial. This binomial that we get is called a difference of squares. Let's break down the terms that we have here. You know, algebra is all about learning what they're asking for, and how you figure that out is by knowing your terminology. Okay, so let me grab a pen here. Let's go with nice purplish pink. Difference. Difference means that implies that you are subtracting. Subtracting what? Now if you're subtracting 2 quantities. So you're subtracting 2 of something. Subtracting 2 what? Squares. Squares is a shortened term for perfect squares. So when we say difference of squares, what we're actually meaning is that it is a subtraction of 2 perfect squares. A subtraction of 2 perfect squares. That kind of lends itself to a checklist. What are the things that you should check for when you're trying to determine if you have a difference of squares? Well, I have a checklist here for you. The first thing is that it must be a binomial. You can only have 2 terms for it to be a difference of squares. So it can only have 2 terms. Okay, that's the first checklist. Check item on the checklist. The second item is that it must be a difference. It must be subtraction. So you have to have a difference or a subtraction of two terms, just like we stated in the definition. Now the next two talk about the perfect square. The first term must be a perfect square, as well as the second term must also be a perfect square. So we broke down the actual terminology, but here's the checklist. Do you have two terms? Do you have subtraction? And are they perfect squares? Okay? Well, once you have determined that you do have a difference of squares, what are the steps to actually work backwards from the product, from the difference of squares to the actual product? Okay, so if I go back a couple pages here, instead of going from these two binomials and going to the product of 9x squared minus 25, we want to start with this and end up with the product, because factoring means that you end up with a product, a multiplication of two items. So here's your steps. Factoring difference of squares. 3 simple steps. Once you have decided, yes, I do have a difference of squares, the first step is to take the square root of the first term. Figure that out. What is the square root of the first term? Write that down. Then you're going to find what is the square root of the second term. So you know that they're perfect squares, so go ahead and take the square root of each of them. Once you have the square root of the first term and the second term, you write what I call the skeleton, and you write the product as parentheses, parentheses, one with a plus, one with a minus. And you put the square root terms in each according spot. Okay? In each spot accordingly, so that it makes a nice product. Okay? So let's look at some examples. You got 6 examples at the bottom. The first one states x squared, it's kind of fuzzy on this paper, but x squared minus 1. Okay? Looking at my checklist, it says it must be a binomial. It is a binomial, so the first check is good. So I'm going to write here that it is a binomial. Check. Second thing says it must be a difference. Here is the difference, so that's also a check. The third item on the checklist says that the first term must be a perfect square. X squared is a perfect square. The last thing says is that the last term must also be a perfect square. And 1 is a perfect square. So we do have a difference of squares here. Okay? Change colors, and let's actually factor this thing out. So once we have decided we do have a difference of squares, we're going to take the square root of the first one. X squared, well, x squared breaks up into x times x. So the square root of that would be just an x. 1 breaks up into 1 times 1. The definition of a perfect square is that it has two factors that are exactly the same. Okay, so we have the square root of x squared is x. The square root of 1 is 1. Now the third step is to write our skeleton. Parentheses, parentheses, 1 with a plus, 1 with a minus. And then you put your perfect squares inside of here. So it's going to be x plus 1, x minus 1. There is your factorization. Of course, you can check any of these by fooling it out. X times x is x squared. X times negative 1 is negative 1x. 1 times x is positive 1x. Negative 1x, positive 1x, they cancel out. Positive 1x times negative 1 gives you a minus 1, so it does check out. And of course, that makes me happy. Okay? Next problem. Next problem states 4x squared minus 36. Let's go through our check system here first. Okay? All right, is it a binomial? 1, 2 terms. That's good to me. That's a check. Is it a difference? Sure is. That's a check. Is this a perfect square and is this a perfect square? Well, a little bit more work here. 4 is a perfect square, 36 is a perfect square, and x squared is also a perfect square. So they're both perfect squares. They're good to go. So we're good to go. We're ready to factor now. Okay. Break down each term into the square root of each term. So 4x squared breaks up into 2x times 2x. So there is the square root of 4x squared. 36 breaks up into 6 times 6. There's the square root of 36. Last step is to write the skeleton. Skeleton means that it is the structure, okay, but then you got to fill in the missing parts, and you fill in the missing parts with the perfect squares. 2x plus 6, 2x minus 6. Perfect. We went from the difference of squares here to a product of two binomials, which is my answer. Check it, pull it out. It's going to end up with 4x squared minus 36. Let's keep going. Next problem states 25x to the fourth minus 100. Okay. Check. Do we have two terms? Yes, we do. It is a binomial. Check. Do we have a difference? Yes, we do. So it is a difference of squares. Well, difference of perfect squares, we have to check. Are these two items perfect squares? 25 is good, 100 is good, x to the fourth is good. So we're good. We do have perfect squares. I'm going to check that off as well. Okay, go through the checklist. What is the square root of 25x to the fourth? Be careful. 25, the square root of that is going to be 5. X to the fourth, the square root of that is going to be x squared. So you can actually break it down into 5x squared times 5x squared. 100, easy. That breaks down into 10 times 10. 5x squared and 10 are the square root of those perfect squares. Next step, write your skeleton. Fill it in with the square root. So 5x squared plus 10, 5x squared minus 10. Okay. Start, finish, answer. These two are factors. It's a multiplication. And if you want to check those factors, you just FOIL it out. 3 good examples. Now, let's get a little bit harder here. Let's test your skills. Look at this one. Let's go through the process. The process doesn't change. Okay, that's what math is. Math is about a process. Do we have two terms? Sure, we're good to go. Do we have a difference? Uh-oh, we do not have a difference. Because we do not have a difference here, this is not a difference of squares. So guess what? We can't factor this one. Sometimes it happens that way. We cannot factor this one with difference of squares. And the reason is that it is not a difference. It is a sum. And a sum means that you're adding. Hopefully you'll catch that. So make sure you go through your checklist accordingly.